This is a demonstration of the world's first multiplayer virtual reality game, first-person shooter. As many people know it, it was on the Plato system. This is a simulation of the Plato system that runs on another computer. We're going to go through a few things here to show you what Plato was like. This is the system that Ray Ozzie got his start on, who is now in charge of Microsoft's architecture. And here we see the number of users on, currently 37. We're going to exit out now to the author mode where programmers write their programs, type in Spasim, which is the name of the first-person shooter virtual reality game. And nobody else is in here, so we're just going to see what it looks like from the standpoint of a first person without any other people to shoot at. But you'll see some of the geometry that was developed, and it's pretty much the same as it was back in 1974. First thing we'll look at are some of the controls. You have the normal directional controls, A, W, D, X, surrounding the S key. The S key was used to shoot. You can do a variety of other things having to do with torpedoes. This is based on Star Trek. And we have 4 teams: agstroms, diffractions, Fourier's, lasers. This is sort of a joke as a way of getting around some of the copyrights on Star Trek's names like Cleons, etc. Here we're going to start heading up 45 degrees away from the space base. We're magnified negatively so we can look out the back of the ship. We see the space base going off in the distance exponentially, and then slowing down so that we can jump back over to the space base and take a look at the ship from the perspective of the base. We're now at the base. We're going to change our magnification so we can get a look at the ship, which is very tiny compared to the base, and it's kind of far away now. It was exponentially going away. And now we can sort of see the outline. Previously it was simply a downloaded character, which was used to try to minimize the traffic over the 1200 BPS modems in use in that era. Remember, this is 1974. And there we can see a front profile of the ship, which is probably recognizable to many people at this point. But we're going to now point the ship straight down and then jump back to the base, and you can see that's the Star Trek starship. So now we set a photon torpedo strength. We fire a photon torpedo, and we are now in control of the photon torpedo. You can see from the base there's a triangular or a tetrahedral object co-located with the ship. If we jump back onto the torpedo, we can start accelerating exponentially again. And with the torpedo, it's a factor of 10 each time. There's the small tetrahedron off of the distance as seen from the base. So the next thing we're going to do is take off and show the base going off in the distance exponentially. We'll see a little planet come in from the top. This is a little bit like the powers of 10 videos you've seen that demonstrate the powers of 10 taking off from galaxies, planetary systems, etc. The planetary simulation has to do with the Club of Rome models that Meadows did. This is done, again, 1974, trying to illustrate the idea of using non-terrestrial materials to make up for the fact that there are limits to growth on planets. We won't go into that in great depth here. It takes some time to go through that process, but basically the idea is you go to your base with your ship, you'd try to load up some anti-entropy, and that would allow you to do things like navigate around, fight wars if you want, or take off to a very remote planet that has a great deal of resources that can make up for the loss of resources on your own planet. Now we're re-entering Spasim. We're going to go in as another team, this time the Fouriers, and you'll be able to see the copyrighted name for those people pretty soon when you see the shape of the ship. again, moving the ship up to 45 degrees and accelerating away, watching from the ship, or watching from the base rather, the ship accelerate away, or I should say exponentiate away. Maybe I should say warp away, because that was one of the ideas. They had exponential warp numbers. And then jumping back on the ship, we're going to turn around and take a look at the base. And there's the base. You'll notice the bases in the various teams are all the same topology. They're just distorted in various ways. Same is true of planets. They're the same topology as the bases, but distorted in such a way as to approximate a sphere. These are all wireframes, no hidden lines. And the clipping isn't very good either. It just simply amounts to going into the center of the object and then either plotting it or not plotting it, no hidden lines, depending upon whether the center is in front of or behind the projection plane. So here we're taking the torpedo into the heart of the base. And we're now just past the central point of the base. It was detonated. Didn't do any damage really to the base. I think that this version of the software might have prevented you from damaging your own stuff. Here we see the ship, base, and torpedo, all three objects you can control, various statistics, and altitude and azimuth, or theta and rho as it was called. And now we can see the ship from the base magnifying up, and it's clear that we're talking about Klingons when we talk about the Fouriers. Jumping back to the ship, take another look at the directions. And we're going to go off and take a little lesson in navigation in Spasim. This is written by Steve Lionel, who I believe was the person who took over the source code after I left Champaign-Urbana, University of Illinois, Searle Computer-Based Education Research Laboratory for Control Data Corporation, Arden Hills operation, to do a mass market version of Plato, but that's another story. So we see the axes going around, so you can get a sense of the actual position of the target point in 3 space in this little tutorial about the difference between Cartesian and polar coordinates. And you're supposed to enter in the theta, the azimuth, and the rho, which is not really the altitude, but is the degrees down from vertical. Looking at it for a little bit, I can estimate it's about 225, and the other angle, it looks like about 135 or something. Yeah, that's pretty close. So now we're going to go in. We're going to skip over the diffractions and go into the lasers. Egg, by the way, was my pseudonym back then. It was a bastardization of the name Agamemnon. And since I was from Iowa, it was sort of a joke that I was the software farmer, and we had something about agriculture in there. Okay, so now the laser ship is taking off from the base, and you can sort of see it looks kind of like an X-wing, which was, I guess, kind of fortuitous given the fact that this was done before Star Wars came out. And now we're turning back around to take a look at the laser ship from the base. Going to magnify up a little bit more. Magnification is basically just positioning the projection plane or the bridge console, the bridge screen, out a certain distance from our direction of view. Moving the cursor up there like that allows us to adjust our direction of view very precisely, and we can go up to 500 magnification and get a good look at this ship. Minimum speed is 1 because anything to the 0th power is 1. And now we're going to take off to see if we can find a planet. There's one around here someplace. It looks like that might have been one. That's closer. That's probably the laser planet right there. Right now we're looking at magnification 10, so things look pretty small. And moving in so that the planet's more in the crosshairs, we can magnify up and we can actually see the approximately spherical grid as we're exponentiating toward it or warping toward it. We warp down to slow down and then adjust our direction a little bit more. We try to see what the distance is to the laser planet. And now we're going to do the powers of 10 thing again, which is just to take off and watch the rest of the universe disappear behind us as we go through the planet. There's no collision detection except with the photon torpedoes in this game, and of course there were laser beams that approximated a spherical projection out from the ship, or I should say a cylindrical projection out from the ship. Then we go to negative magnification to see out behind the ship, and we can see the planet warping away from us. And as the planet warps away, then other planets come in and converge, and we finally blow ourselves up from too high of a warp speed, and we are welcomed to whatever. That was a little drawing by Dave Fuller. I did the star cross by cubing some random numbers between -1 and 1. Now we're looking at Plato Notes, which was the inspiration for Lotus Notes by Ray Ozzie. And just reading through a few of the comments. We'll take a look at some of the commands that are available to the readers of the notes system. They're called group notes on Plato. Different groups had their own notes files, and the Spasim's group's notes file was reasonably active. And here are the options that are available to readers of Plato group notes. But of course, group notes is only one small aspect of the Plato community that inspired Ray. There's a demo.